Hey there kiddos, welcome to another video. This one is for Module 1, Lesson 12. And in this very interesting lesson, we're going to be doing some estimating. But how do we get there? Well, we're going to be multiplying a decimal fraction by single-digit whole numbers, including using estimation to confirm, which means make sure that we are right, the placement of the decimal point. So if you have a chance to talk your teacher into doing Lesson 9 sprints, it is an excellent warm-up to pay attention to rounding to whole numbers and get you multiplying. But if you don't, maybe you can do it on your own if you have access to Zern. This is a little bit from the teacher's edition that has the concept being taught. It is taking a look at whole numbers, for example, 31 times 4. Those are all ones. There's no decimal around. And then looking at how do I multiply using the standard algorithm. It would be 4 times 1 for 4 ones, 4 times 3 for 12. And by this time, we're multiplying 4 ones times 3 tens, which should give you 120, which is why the place value positions are what they are. Now notice that this is all ones and there are no decimals. So here we have decimals being tossed out at you. And so we have 3 and 1/10 times 4. So this is part 2. So what do I do with this? Well, it's really not that bad if you take it and make it unit form. And unit form just means instead of putting the decimal in, put the word in. So use 31/10 times 4 ones. Still multiply 31 times 4. I know it's 124. I already have the answer here. I worked it out. But where do I put the decimal? That's the question. So tenths times ones will give you tenths. And when we use the standard algorithm, we'll confirm that in future lessons. So the next one, it looks a little more complicated because they have this 0 here, and it's still the 3 and the 1 times 4. So it's 31 hundredths times 4 ones. And so here again, using unit form, 31 hundredths times 4 ones to give us the 124, which I know I have, same digits being multiplied, same product, but not the same placement of the decimal because I don't have the same value here. This is 31 tenths, this is 31 hundredths. Big difference in your decimal placement. Hundredths times ones will give you hundredths. So we go ahead and place all that here. And I say, let's use an area model because we will probably see a couple more of these in Lesson 12. So if you take your single digit whole number, put that on the outside like we did in Lesson 11, and then set it up on top with your decimal values up here, 0 ones, 3 tenths, 1 100th, and then multiply it through using unit form here. Write your standard form there. Don't let the 12 tenths trick you. It ends in the tenths place for a 1.2. Don't let the 4 hundredths trick you. It's got to be way over here. This is the tenths. This is the hundredths. If you line it up using the addition and place value strategies, you'll see it's very easy to add these because we only have like a single digit other than 0 in a lot of the columns. So it's very, very easy to add. Now when it gets a little bit more complicated, when you have something that has a carryover. So if you have 7 and 8 tenths times 3, but you use unit form, look at the standard algorithm, okay? Take out the decimal, call it unit form, multiply like you would. You should have learned this in 4th grade. 3 times 8 is 24. 4 goes down, 2 goes up. 3 times 7 is 21, plus 2 is 23. Okay, now what do I do with the decimal? Because I had a decimal in my original problem. Well, here's the label, tenths. Here's the 1 label for ones. Tenths times ones gives you tenths. And so now write 234 tenths in standard form, which is 223.4 or 234 tenths, ending in the tenths place. Okay? Last sample problem before we get in the book. 3 and 12 hundredths times 4. Again, it's not as hard, but if you take out the 312, take the decimal, make it uniform, times ones, call it hundredths. This one doesn't have any regrouping really. 4 times 2 is 8, 4 times 1 is 4, 4 times 3 is 12, so there's nothing to carry over. You just have to read very carefully and know where to put the decimal. 1,248 hundredths. Remember, if we rename it that, we can write it in standard form. Last example is using the area model for this same problem, putting your 3 and 12 hundredths on the top, multiplying. I didn't write all the problems, I just put the answers in here, and then having standard form on the bottom. You can add it all up over here, still get the same answer. So now you have a lot of tools for your math tool belt, which is what we're trying to give you in this program, is to help you when you have a question so that you know what to do. Excuse me. Okay, here we go. I'm going to get some water. All right, off and running. Okay, so we're going to choose the reasonable product for each expression. Reasonable. Make it make sense. But we do have to explain our reasoning in the spaces below using words, pictures, or numbers. So the reason that sprint was a great warm-up is because we're really going to be paying attention to the whole numbers here, because we are explaining what's happening with the placement of the decimal. So I know the warm-up doesn't seem like it connects that well, but you'll see when we have to start explaining. So if I really have approximately 2 times 4, you're saying, what's happening with this? Well, in estimation, I can use the decimal fraction in a little way, or I can drop it. And so what I just want to know is, what am I close to? So roughly 2 times 4, somebody out there's going, hey, change it. Roughly 2 times 4 is going to be 8. I just couldn't wait to get to the answer. So approximately 2 times 4 is 8. Even if I bump that up, let's say I bump it up to 3, and I do 3 times 4, what would I get? Yep, 12. Now, these are your choices, okay? Choose the reasonable product. Product is an answer to a multiplication problem. You have to know that. Okay? Have to know this word. An answer to a multiplication problem. So, which one is reasonable? Is 1/10 reasonable? No. Is 1 reasonable? Well, it's more reasonable than 1/10. Is 10 reasonable? 10 is between 8 and 12. Yes, 10 is reasonable. Is 100 reasonable? No. It has too many place value positions. The key here in this lesson is to pay attention to where the decimal is, if you have one, or how many place value positions they are providing you in your choices. So this is a single or 2-digit small number close to 10. 10 is my choice. It's the obvious choice. So basically what you could say in your explanation, if you were to think about the unit form, what about 25 tenths as a whole in unit form times 4 equals approximately 100 tenths? Okay? And 100 tenths is equal to this, which is 10. So that's where the lesson all comes together. You're trying to figure out, well, what am I close to? Where does the decimal fall? How many place value positions should I have on the left and the right? So let's do another one. We'll keep going. You'll get the hang of it. Okay, now roughly 3 times 7. That's approximately where we are. I need something around 21. Okay? Now, it's a little higher. It's going to be a little higher. My product will be a little bit higher than 21 because I have a little bit more than 3. So does any number here stand out as a little higher than 21? You should say, yes, this one does. Why? Because I have 21 ones, and if I had any of the other choices, the decimal placement would not make sense. Okay? So it's going to be a little bit higher than 21. The whole number, 3 times 7, the whole number is 1 multiplied, will get you 21. 14 hundredths 7 times is not going to amount to much, maybe 1. Okay, and so this 98 hundredths adds up to about, that's almost 1. Okay, so let's explain. 3 times 7 is what we're going to do first, but plus a little extra would give us is 21.98 or 21 and 98 hundredths. Okay, so there's your explanation. You want to get it to the right place value. I need 21 ones, and if I have anything else, it's going to be too much or not enough. 2 is way too small, 219, way too big. Let's do another one. Same idea here, 8 times 6. That is 48. Okay, so when I multiply 8 times 6 and this teeny tiny little amount, it's going to be 8 times 6 plus a little extra. And so what would be the logical choice? 4, too small. 48, yes, that looks about right. 481, really big, way too big. Okay, ridiculously large. Okay, notice the digits are all the same, 48176, 48176, 48176. It's just the placement of the decimal that they want you to focus on. Okay? Last one here on the front, 9 times 5 is 45. So I'm really just looking here. Now this is almost halfway. Remember, 48 is almost 50, and from the vertical number line, you know that 50 is our halfway point where we could go up. So if I have 9 times 5 and that's 45, even if I did 9 times 6 and got 54, I'm still only having a 2-digit answer. So this is too big, this is approximately correct, this is too small, this is way too small. So your explanation, again, 9 times 5 is about 45, which is 2 digits, and then plus a little extra. And it's going to be half 9 times. So that will add up to a few wholes. That's why we end up with 9 in the ones place. Okay, so let's move on. We've got some word problems on the back that will take you a minute or two. Pedro is building a spice rack with 4 shelves that are each 55 hundredths of a meter long. Okay, now 55 hundredths is approximately half. It's a little bit more than half of a meter. At the hardware store, Pedro finds that he can only buy shelving in whole meter lengths. That's right, because you can't walk into Home Depot or Lowe's and say, hey, can I have this piece of wood at this fractional length? They'll say, nope, you can't. Exactly how many meters, of shelving does Pedro need? So that's one question right here. Look at that question mark. Exactly how many? Also, since he can only buy whole number lengths, how many meters of shelving should he buy? There's another question mark. Now we have to justify our thinking. So we have to show a little bit of work here. So if we have our 55 hundredths of a meter for the space that we're working with, and we need 4 of them, then we're going to have 4 times 55 hundredths. If you use an area model, like we did previously, you can break down, remember if I have 0 ones, I can have that section there, but you don't have to take up a lot of space. 5 tenths and 5 hundredths. This can help you break the problem apart. So 4 times 0 ones is 0 ones. 4 times 5 tenths is going to be 20 tenths. 4 times 5 hundredths is 20 again, but new label, hundredths. Standard form on the bottom, 0. 20 tenths, what does that look like? Well, it has to end in the tenths place with the 0. 20 tenths. How about 20 hundredths? Well, that's going to be like this because we have to end in the hundredths place, 20 hundredths. Now, if you add these vertically, so you line up your 0, then you line up your 2.0, then you line up your 0.20, then you will have your 2 and 2 tenths meters of shelving. Okay, so this is exactly the amount of shelving that Pedro needs. Okay, so exactly for Pedro. But when you walk in, if you say, may I please have 2 2/10 meters of shelving, they'll say, no, you may not. But we could sell you 1 meter or 2 meters or 3 meters. What would you like? Well, if you get 2 meters for your project, will you have enough? No. So you need to bump it up. And I know that you wouldn't normally round a 2 and bump it up, but if you round it down and you only get 2 meters, you won't have enough to complete the job. So purchase 3 meters of shelving so that you can complete the job. Okay, so we have to bump it up. You have to use that little extra and say, you know what, I might have some stuff left over, but it's better than not having enough. Okay, moving right along. Marcel rides his bicycle to school and back. He comes home, hooray, on Tuesdays and Thursdays. He lives 3 62/100 kilometers away from school. Marcel's gym teacher wants to know, just give me a rough number, about how many kilometers he bikes in a week. Marcel's math teacher wants to know exactly how many kilometers he bikes in a week. What should Marcel tell each teacher and show your work? So we want to make sure he goes to school and back, and to school and back. And this is only on Tuesdays and Thursdays, so we'll say Tuesday, Thursday. Now, how far away is he? 3 62/100 kilometers each ride. So when we set this up, you can make a tape diagram. Very handy. Tape diagrams are actually kind of awesome. I used to hate them when I first started teaching this program. I was like, what? Why? But what it does is it makes a picture, and then the pictures can help you solve a lot of the word problems when information is missing, because the tape diagram will fill in a number for you. So anyway, a tape diagram shows a part to whole. So what this is showing you is this is Tuesday and this is Thursday. So we have the parts of each ride on both days. So this looks a lot like repeated addition, doesn't it? Or repeated addition becomes multiplication. Now, standard algorithm, if you want to use it, of course, I always encourage using the standard algorithm whenever you can. It's 4 times 3 62/100. So let's work with this. 4 times 2 is 8. 6 times 4 is 24. Carry the 2. 4 times 3 is 12. Plus 2 is 14. If I have hundredths times ones, I will get hundredths. Now that's going to be exactly how many kilometers he bikes each week. But for those of you who are still kind of lost, you can use an area model and do 3 ones, 6 tenths, and 2 hundredths, and see how that plays out. 4 times 3 is 12 ones. 6 times 4 is 24 tenths. 2 times 4 is 8 hundredths. THS. Let's make standard form and add them up and see if we get the standard algorithm. 12 ones. 24 tenths, remember, looks like this, because when you rename it or change it to unit form, it's got to end in that place. 8 hundredths, not here, but here. Add these up. 12 ones, 2.4, and 0.08. And we end up with the 8 and the 4 decimal down, 4 and the 1. 14 and 48 hundredths kilometers. So exactly for Marcel's math teacher, Okay, so now you've proven your answer for the math teacher, but the gym teacher wants to know approximately how many. Now, there are a couple different ways you can do this. I've seen students do 360 hundredths. I've seen them round it to 4. There's no specific way that they tell you to round. It doesn't say tenths or hundredths or ones. So a lot of students will just take the 14 and 48 hundredths and round that to 14, so it's approximately 14 kilometers each week. And I've seen lots of different methods there and lots of different explanations, and I usually say, oh, they're all good. That's all good. More than one answer when estimation is your option. Okay? And that's for the PE teacher or gym, whatever. It's all the same thing. Gym, PE. If you don't have a gym, it's PE. Okay, last one. Oh yeah, click subscribe and come back again. The Poetry Club had its first bake sale and they made some cash flow, $79.35. Yay! The club members are planning to have 4 more bake sales. Awesome. Leslie said, if we make the same amount at each bake sale, highly unlikely, but okay, we'll earn $3,967.50. That's a lot of money, Leslie. Peggy said, no way, Leslie. We'll earn $396.75 after 5 bake sales. So notice the digits. 3s, 9s, 6s, 7s, 5s. There's a 0 here, but no 0 here. Placement of the decimal, I have 4 digits to the left. I have 3 digits to the left. So we're off by 1 place value position between these two girls. If we use estimation to help Peggy explain why Leslie's reasoning is inaccurate, that means wrong, not accurate, we can show what's happening with these decimal places. So we're going to use estimation. Show your reasoning using words, numbers, or pictures. When they give you a choice, you can use what is best for you. So I'm going to take the $79.35, $79.35, and they want to have a total of 5 bake sales. They made $79.35 for the first one, right? But they want to have 4 more. So this is where your tape diagram can come in handy. They want to have 4 more after having this one. So if you take your $79.35 and you multiply it, well, actually, we just need to use estimation. So we're going to say that's approximately what? Notice the whole number. It's approximately 80. I only need to use estimation. So if I were to say, how much would we have after 5 bake sales, which is our statement here. So we're going to use these words to help us. If I have approximately 80 times 5, multiplying the 8 times 5 gives you 40, and then multiplying by that 0 will give us approximately 400. $396.75, make it money, is very close to $400, make it money, but too far from the big number, $3,967.50. So basically, Leslie just estimated wrong. Okay, so Leslie estimated wrong. Or she placed the decimal in the wrong place, which is, common. And it can happen to anybody. It'll probably happen to you, and it'll probably happen to me at some point in the future. So anyway, I hope this is super helpful. Come back again on another video. We'll see you soon.